Good evening, YouTube. Welding thin stainless again, but I kind of learned something this week. A guy came in and said, "Oh, I struggle with this stuff. It doesn't work. It just goes wrong for me." And I said, "Well, I used to, but I'm kind of getting there." So we set up our little fixture here. I welded some, he welded some. We decided to look at the difference, see where we go. And I think we both learned something. Now the main issue, main difference between him and me was travel speed. Simple as that. And it was a big difference. So hopefully that's what we're going to kind of replicate tonight and show you. So keep watching. You might learn something. I know I did. Right, so this is bead number 1, and if you want a good travel speed, get comfortable. Take dry runs, go as far as you're going to go with that bit of weld. 300 series stainless, you don't have to worry about stopping, it's not terribly crack sensitive. Take dry runs, make sure you can move at speed without getting your rod caught up, or your torch caught up, or your cable caught up. Okay, then get the pedal down, get the heat in, get going. Try and get going in a second or less, and then move. Dip, 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 don't hang around. Okay, so that is bead 1. I will just run this clip once more and I'll bring the sound back. Hopefully what you'll hear is each time the rod is dipped a little clicking, ticking sound, and that's an indication that your arc is tight enough, short enough. Right, for the next one, all I'm going to do is restrict the amps a little. Now it's 30 thou stainless, I got it set to 40 there, which means full pedal will be 40, not quite using full pedal. I'm going to just restrict myself by turning these amps down to a little under 30, which will be barely enough to get moving quickly, and we will see what effect that has. Alright, same piece of metal, same fixture. I'm now lighting up. I've floored that pedal, but I can't really get moving straight away because the pedal wasn't ready, and I can't really step out as far because it's struggling to melt the metal. And hopefully this is going to be a good example of the less amps, more heat input thing that a lot of less experienced TIG welders are going to run into. I know I did. Things happen quite quickly, so you tend to back off the pedal and try and go slower. That actually results in more heat input, because heat input is a function of travel speed as well as amps. If your amperage is low and you can't get moving, your total heat input can often be higher because of the time it takes to complete the weld. Now we'll get these welds out of here in a minute and just have a look, see what gives. Right, firstly, neither weld looks particularly good. Reasons for that we'll get into later, another thing to show you. But this is the first weld that was welded at a reasonable speed, and it does show a bit of promise. It's not crowned up, it's reasonably shiny, and the penetration is through the other side. There's been a lack of gas coverage on the back, which we'll talk about in a minute. So, and this is the one, all we did was cut down the amperage, which restricted our travel speed, and what we've actually got is more heat input, a wider heat affected zone, a weld which is starting to turn grey, which is a sign of overheating on stainless. Also the gas coverage may be lacking slightly. Now sometimes on plain carbon and alloy steels it's desirable to move a bit slowly to let the heat build up in the part to avoid quenching and cracking. Not necessary on 300 stainless. You can, if you can't move, if you get in a bind, just stop. Looking at the other side now, it's clear that the heat affected zone is much wider on the part that was welded more slowly. So it's a good example of the less amps, more heat phenomenon, if you like. Okay, so with 300 series stainless, get the heat in, get moving, and it will improve the standard of your welds. That's one thing that's important. Right, I said that one of these welds didn't look particularly good. Neither of them looked particularly good. So what we're going to do this time is deal with that. And one of the real issues that will cause you problems with stainless is cleanliness and gas coverage. So this time I'm going to clean this weld with fresh sandpaper that hasn't been used with anything else. We're going to wipe it with acetone to get it really clean. We're going to wipe the rod with acetone. We're going to sharpen the tungsten to a needle point, and we're going to break out this Furick cup. I think it's the Fupa 12. Really good cup. We're also going to purge the underneath, the backside of the weld with argon. So let's see how it goes this time. Again, I've got the bigger cup, needle sharp tungsten, ultra clean, everything's clean. And we're going to try and light up and get moving, just like we did with that first one. Amps in, within a second, move, and then dip and move. Really as quick as you can. This chill bar is giving me just a little time, this fixture, to get my head together before it all runs out of control, distorts and goes wrong on me. But I'm still having to get going. See, I'm dipping more than once a second, almost half a second, just to keep that moving and stepping out a good eighth of an inch each time. And we'll see what we've got. Alright, so we are beginning to get somewhere near where we want to be now. This one too slow. This one the faster travel speed. So that's a good example of the more amps, less heat input, because it gets you moving quicker. But this one, this last one with the Furick cup, gas coverage, top and bottom, both sides of the sheet were much better. The weld is shinier, the penetration is smoother. We'll get a look at this in a minute in some daylight. That's probably going to pass you a test. That's closer to where we want to be. Right, we're in the daylight now, it's a bit more forgiving. That's the back side of the weld. Silver, not oxidized due to the good gas coverage, reasonably smooth. And the top side of the weld, the side we welded, actually doesn't look too bad. I've seen worse, I've done worse, and that would probably pass your test. In fact, it has for me on many occasions. So it's closer to where we want to be. It's not beautiful, it's not Instagrammable, closer to where we want to be. So travel speed, cleanliness are the things that matter more with stainless than they do with carbon and alloy steels. My mistake earlier in the video. This is not a Fupa 12, this is a BBW cut by Mike Furick, and it's an excellent, beautifully engineered, beautifully made thing. If you're doing test pieces like this, it's awesome. Fantastic gas coverage. Anyway, I hope you enjoyed the video. I know I learned something when somebody came in and said I'm having problems welding this stainless, just by looking at what he was doing wrong and showing what he was doing wrong. So I hope you learned something from this video. Again, I'm no expert. It's just sharing some of my experience and what I've learned. Hopefully it will help some other people. Thanks for watching. Good night.